The year 2030 is approaching fast, and it marks a specific, highly anticipated deadline across the tech industry. It is the target date for multiple, distinct technologies to mature and converge all at once. Right now, we are hitting a wall. Take generative AI. It can write code and draft essays, but it is entirely reactive. It sits idle until a human types in a prompt, severely limiting its ability to handle continuous, complex workflows. The transition to clean energy is facing its own roadblock. We can harvest solar and wind power, but we lack the infrastructure to efficiently store that electricity for days or weeks when the weather doesn't cooperate. In computing, our current quantum machines hold massive potential, but they are highly unstable. They generate too much noise, microscopic errors that make them unreliable for solving practical, real-world problems. And then there is the way we physically interact with the digital world. We are bottlenecked by staring down at 6 inches of glass, restricting our digital lives to a small handheld frame. Overcoming these limitations doesn't require a single isolated invention. It requires an entirely new, interdependent technology stack to come online simultaneously. Every technology stack starts with a physical foundation. To reach that 2030 convergence, we need massive upgrades in how we generate power and process information. On the power side, advanced storage technologies like solid-state batteries are scaling up. By holding wind and solar energy for weeks at a time, they provide the reliable backbone necessary to run a fully clean economy. Meanwhile, classical computing is bumping up against the physical limits of silicon. To keep progressing, we have to transition to fault-tolerant quantum computing, machines that can correct their own errors. This is the roadmap for a system called graphene, currently being developed by the quantum computing company Alice and Bob. They are targeting 2030 to deliver a universal, error-corrected quantum computer. Their approach solves the noise problem using cat qubits. Unlike fragile standard qubits, their unique architecture naturally resists bit flip errors. When strung together, they create an error correction net, yielding a single, highly stable, and incredibly powerful logical qubit. With this stable hardware foundation in place, we gain the raw processing power required to solve complex material science and chemical engineering problems that classical computers simply cannot handle. Once we have the power and processors, we move up the stack to the software layer. This is where artificial intelligence transitions from generative to agentic. Generative models wait for you to ask a question. Agentic AI possesses memory, perceives its environment, and has the autonomy to initiate actions without a human pulling the trigger. Companies like Fujitsu are already building frameworks for multi-agent ecosystems. In these networks, different AI agents continuously negotiate, coordinate, and execute complex workflows across entirely different organizations, all simultaneously. Instead of asking an AI to draft a simple email, a user will deploy a team of agents to monitor and manage an entire global supply chain, completely removing the human bottleneck from digital execution. At the very top of the technology stack sits the interface layer, the physical point where humans interact with all this underlying computation. Mark Zuckerberg predicts that within the next decade, augmented reality smart glasses will permanently replace the smartphone as our primary connection to the digital world. Wearing AR glasses brings agentic AI directly into your field of vision. Digital workspaces, data streams, and communication interfaces are projected seamlessly onto your environment. By taking the screen out of our pockets and placing it over our eyes, we get a hands-free, omnipresent interface. It is the only way for humans to visually keep up with the speed and volume of autonomous AI. When a new infrastructure of this scale comes online, it hits the human layer last, and it triggers a massive labor shift. The World Economic Forum projects a severe transformation in the global job market between 2025 and 2030 as this technology stack matures. This chart shows the fastest-growing jobs globally, with explosive demand for big data and machine learning specialists. But in the corresponding data for declining jobs, there is a sharp drop in clerical and administrative roles, as agentic AI automates those routine tasks directly. This creates severe job polarization. Routine execution is no longer a human task, leaving cognitive adaptability as the single most valuable commodity in the workforce. This transition carries immense friction. There are deep ethical concerns surrounding algorithmic bias in new models, and the resulting job displacement will disproportionately impact vulnerable and marginalized communities. To navigate this, the definition of work has to evolve. The successful worker of 2030 will no longer be a raw producer of content. Instead, they will act as a manager of AI agents. That is the complete 2030 stack in motion. A human operating through AR glasses, directing AI agents on complex tasks, all processed by quantum computers and sustained by next-generation energy storage. The physical and digital infrastructure of our world is upgrading. To maintain our place within it, human capital must actively reskill and upgrade alongside it.